Hello, my name is Lucas Ferrandi, and I'm going to talk about some aspects of the initial conditions that are formed in nuclear collisions. My research was oriented by Professor Marcelo Gameiro Munhoz from Instituto de Física da Universidade de São Paulo. First, I'm going to talk about the Cloudberry Model that I used for modeling the nuclear collisions. This model sees the nucleus as a set of smaller particles, like nucleons, and these nucleons can be such as protons and neutrons. These models use geometry to calculate the probability of interaction of each nucleus in the collision. What I did was simulations using a program called GLISSANDO. It is the third edition of this program, and it was created by a group of Polish physicists. This program uses Cloudberry Monte Carlo. It means that it generates the positions of the nucleons in each nucleus, and this position is not random, but it follows a given probability distribution. I chose Wood-Saxon distribution, if you can see here in the left, and I chose the wounding profile as a Gaussian function to tell us how the nucleons will interact. Here are some results that I obtained simulating PB-PB collisions at LHC energies. In the first line we have central collisions. We have impact parameter of 0 Fermi, and we can see that we have a high degree of inhomogeneity. This means that some regions, these yellow dots, are very prone to generate some particles like heavy quarks, because these regions have a higher energy density. These quarks are important to probe some parameters of the evolution of the system, and like some parameters of quark-gluon plasma and the hadronization of the system. In the second line, we can see the simulation for peripheral collisions. We have a high non-isotropic system because of the geometry of the system. We can see here that this interaction region is not isotropic, and this reflects in this geometry, and this can reflect in some results that are measured in colliders like the LHC. Here I plotted the number of wounded partons for each of these nuclei for each class of centrality, and we can see that we obtain a very nice linear fit for this parameter, and this way we can predict the results of wounded partons for different nuclei. And on the right side I plotted the angular coefficient of this class of centrality in function of percentile, and we get a nice law here as well. And we can use these results to predict what we can obtain using different nuclei on colliders. And I like to thank FAPESP for the financing of my research. I'd like to thank this reunion for the possibility of presenting this, and I'd like to thank IFUSP and EPIC for the knowledge that I obtained on the last months and years, and thank you.